All right, let's talk about volume of prisms and cylinders. My opinion, volume's easier than surface area, and for the most part. That's why I like to save it till the end. But let's go ahead and talk about this. Volume is the amount of space enclosed in the interior of a 3D figure or an object. So it's filling up the prism. It's filling up the cylinder. It's, let's say, filling it up with water. Okay, that's what volume is. Even if you fill it with sand, how much is in there? We are going to be going into a third dimension now, okay? So we will be using our units cubed. So first of all, the formula. The formula for volume of any prism is big B, little h, which we've already discussed. Big B is area of the base. H is going to be that height connecting the two bases together. First one here, we're going to see all rectangles. So that tells us we have a rectangular prism. All right? And so now we're going to, we don't need to find big P anymore. All we need is big B and little h. So big B, the base, we'll go ahead and use the shaded area as our base. The base of a rectangle is base times height. So we're just going to multiply the two numbers together. And big B will come out to 48. Your height is going to be that connection. Grab the right pen here. It's going to be that connection between the two bases. So right here, this is going to be your height. So we use our formula big B, little h. I'm just going to go ahead and plug in right here. Big B would be 48. And your height of the prism is going to be 2. We multiply these together. We are going to get 96. And we don't have units listed, so we'll just put units. We are now cubed. We're going 3 dimensions now. Okay? In reality, what's going to end up happening with a rectangular prism only. With volume, you simply just multiply the 3 numbers together, because look what we did. We did 8 times 6, and then we multiplied it by the 2. This only works with rectangular prism, though. Right? Next, I see a triangle. I know I'm doing prisms. I see a bunch of those rectangles that tell me I've got a prism, and then I see a triangle. So we're going to have a triangular prism. So again, we need to remember that our base is going to be that triangle. So that's what we're finding big B. All right, that's what we need to use. So right here, this is our base. So to find the area, big B, area of a base, we need our base times height divided by 2. Okay? So we take a look at our rectangle. We have our base of 12. We need to find the height. So we're going to go to the side, and we're going to say, okay, let's use this back one to find the height. Here, we draw this triangle off. We just kind of look at this triangle right here. All right. We're looking for height. We have this leg over here because we know 12. We split it in half. This is 6. So we're going to have a Pythagorean theorem of our height squared. Put it over here to the side. We have our height squared plus the other leg is 6 squared is equal to the hypotenuse 10 squared. And I encourage you to pause this, work it out. I'm going to pause it, and in just a second you're going to have all the work and the answer. Please pause it now. So we should have found the height of the triangle, not the prism, the triangle, to be 8. So I plugged it in the picture, and I plugged it in over here in that same color. Okay. Once we have solved for big B, we are done with that 8. Throw it away, ignore it. We are no longer using that 8. Right? When we solve for big B, as long as my math is correct, we're going to wind up with 48. Weirdly enough, the same area of the base in the last one. So now we're going to plug in for our formula, area of the base times the height. Remember, your height connects your two bases together. So it's going to be the pathway from one triangle to the next. Okay? So again, that H for right here, the base, we're done with it. We're finished with it. Completely ignore it. Okay? The H in our volume is going to be this 4 right here. So we'll plug in big B, 48, times our height of the prism, 4. We should come up with 192 units cubed. Again, 3 dimensions now. Next, I am seeing here my base. We're not sitting on the base, but we have our 2 parallel sides. The rectangles are our lateral faces. So our base right here is a hexagon, so we have a hexagonal prism. To make this a little bit easier for you, we went ahead and gave you big B, okay? And we just need to remember that your height is going to be what's connecting the two hexagons together, okay? So we have big B, 93.5, times that height that connects the two bases, two hexagons together, 12. When we multiply these again, hoping that my original math and my answer key is correct, 1,122 units cubed. It's very important to write these units cubed, so we're seeing volume is three-dimensional now. Next, we have a trapezoid. We're very, very lucky, and we were given the big B again, but because our base is going to be this trapezoid, doesn't matter if it's sitting on it or not. We're looking for in prisms, we're looking for what's not the rectangle, unless it's a rectangular prism. So this right here is our base. And since it is a trapezoid, that fun word, trapezoidal prism. So they gave us a big B. We remember that the height is going to be the path that connects, or the edge, we should have our vocabulary, that connects the two trapezoids together. Okay? How do I get from one trapezoid to the other? By taking the height of 10. So here, big B of 36. Times the height of 10. Easy to do in your head, guys. The rules of multiplying by 10. Take the number, 36, add that 0 onto it. So we have 360 units, again, cubed with that 3. All right, let's take a look at cylinders. See how nice and easy cylinders are. Your cylinders formula, again, volume, same thing. It's going to be, so now we're filling up the cylinders. So think about how much is in a can of soup. Okay, that's what that liquid, that's what the volume is. Here, your volume is going to be equal to pi r squared h. We're taking the area of the base and we're multiplying it by the height. Okay, because we have to stack all those circles together to get all the way up, filling up that volume. So we'll take a look at our problem here, and I see that we have the radius that's given to us of 3. My height right here, from base to base, is 6. So when we plug in, our volume is going to equal pi times our radius squared, 3 squared, times the height of 6. We're going to round to the nearest tenth, like we've been doing with these, okay? And when we plug this in, and I encourage you, whether it's before or after I put the answer, plug it in yourself. Do not use 3.14. You need to use the pi button. We should come up with 169.6. The units are inches, so we have inches cubed. Next, we're given our radius right here of 8, our height of 12. So let's plug in. We have pi times our radius squared times our height of 12. Plugging it in on your own, whether it's before or after, make sure that you're getting 2,412.7 inches cubed. Last one, do not say the height is 15, because it is not. Okay, a lot of students see that up and down like, oh, okay, that's mine. No, that is in the circle. This is your diameter. So your diameter is 15. So we're going to write in our radius as half of that, which would be 7.5. Then I'm going to scratch off the diameter so I don't accidentally use it. And fill in my radius of 7.5. Your height connects circle to circle. Even though it's laying down, your height's still the same from your head to your feet, even when you lay down, 18. We'll fill in. We got pi times your radius squared times the height from circle to circle. Yeah, making sure that you're doing this on your own and seeing what we have in the end. 3,180.9. We have millimeters, so we have millimeters cubed. And that's volume.